All right, so page 204, domain and range. Before we get going too far, just remember domain, and it will tell you this later on. Domain is always going to be known as the input. Your x value will always get plotted on the x-axis. Obviously, the range is the opposite of that. It's the output and your y value. So as earlier you saw a situation for the total number of barks a dog, total number of times a dog has barked was a function of time in seconds after its owner tied its leash to a post and left. Less than 3 minutes after he left, the owner returned, untied the leash, and walked away with the dog. Could each value be an input for the function? Be prepared to explain. So could 15 be an input? Remember, input was the number of seconds. Okay, so what's 15 times, let's see, seconds? 15 seconds. So be any issue with 15 seconds? No? That's less than 3 minutes. So that would be okay for an answer. How about 84 and a half?
Can't really have a half a second.
Well, you could.
Well, I guess, but it's not really likely. So
I mean, is that less than the 3 minutes still?
yeah.
Yeah? So that one's fine. How about 300 seconds? Why doesn't that one work? Yeah, it's more than 3 minutes, right? So our max would have been 180 seconds. So this one does not work. All right, now it's asking for an output. The output was the number of barks. So this was time in seconds. Is it possible a dog could bark 15 times?
Yeah.
Eighty-four and a half.
Yeah. Oh.
No, can't have a half a bark, right? Can't have a half a bark. 300.
Yeah. Maybe he's just a really barky dog.
Yeah, I mean, it is possible. That'd be 100 barks a minute, though.
Fine.
That would be pretty crazy. So I suppose it is possible. If you have a dog that barks 100 times in a minute for 3 straight minutes, I don't know what to tell you. I don't think that's good. All right, it says your teacher will give you a set of cards. We're going to look at some here together. Decide whether it is possible based on our description here. Sort the cards into 2 groups, possible inputs and impossible inputs. You know, does it work and does it not? So why don't you read that first question for me, Georgia? What are we
The area,
considering?
the area of a square in square centimeters is a function of its side length s in centimeters. The equation a(s) equals s squared defines this function.
Yeah, so the input will be right here. So our input is side length. So I'm just going to show you these, and if you see some side lengths that you think would work, let's put it down for possible. Side lengths of a square.
9, 4,
9, 4.
many.
How about one more for possible? 7. Could you have 6.8? Yeah, I mean, it could be 6.8. Doesn't have to all be whole numbers.
Can't be negative.
How about some things that don't work?
Negative.
Yeah, negative 18, negative 3. Yeah, I think you could argue 0 as well. I mean, it's not a square if the side length is nothing. Question number 2. Samira.
A tennis camp charges $40 per student for a full day camp. The camp runs only if at least 5 students sign up, and its limits the enrollment to 16 campers a day. The amount of revenue in dollars that the tennis then equation Rn equals 40 and define this function.
Yeah, so now my input is number of students attending this camp. Okay, so again, looking at the numbers there, which ones do you think work? Give me 3 numbers that'll work for number of students.
6.
I don't even see a 6.
Well, I'm just thinking in my head, but
9,
9,
okay. 15.
15,
and
72.
72.
No, can't have more than 16.
Oh,
Oh, yeah, it can't be more than 16. How about 4?
no. 'cause you can't
4 doesn't
put
work
some
either,
on.
so just 9 and 15. At least 5 and less than 16. Okay, so numbers that don't work.
4.
Oh, you already told me 72 doesn't work. And 4. Obviously, decimals, fraction of a person. Aren't gonna work. List as many as you want. We got a few there. Question 3. Connor, would you read that one, please?
In an earlier activity, you saw functions.
Nope, sorry, right above there. This number 3.
The relationship between temperature in Celsius and the temperature in Kelvin can be represented by function K. The equation defines this function, where C is the temperature in Celsius and C is the temperature in Kelvin.
Okay, so C is temp in Celsius. Celsius, degrees Celsius is our input. Which ones work? Which one could be temperatures?
Really, anything?
Yeah, can any of them not be? Any of them not be temperature?
Well, I guess.
I mean, you could technically have that temperature. That's pretty
Not
accurate.
on there, but it could be like 1,000 degrees is not really possible. Yeah, you're fine.
I don't think from our list here we have,
Well, I'm not
Any.
saying, wait, that was, do we need that?
I mean, 3/5 is 0.6 degrees. So I would say they all work. Temperature, it doesn't matter if it's a decimal, fraction. Most of the time we worry about whole numbers, but it is possible. Question number 3. Jackson, would you read that, please?
In an earlier activity, you saw a function representing the area of a square, function A, and another representing the revenue of a tennis camp, function R. Refer to the descriptions of those functions to answer these questions.
All right, give 3 possible input-output pairs. So side length and its area, we just did that from your chart, from your homework. If the side length is 2, area is 4. Side length is 3, the area is 9. Side length of 5, area is 25. Pick 3. Came right from your table that we just did. Again, your S is your input, that is your side length. That's where those numbers came from. Earlier we described the set of all possible values of A of any possible greater than or equal to 0. How would you describe the set of all possible outputs? So all the possible areas, how would you describe it?
They have to be more than 1.
Yeah, more than a 1. I mean, you could technically, we did have 0, 0 in our chart. So you could say the area has to be greater than 0. I don't think we can say it's got to be equal to it, because I don't think it's a square if the side lengths are 0. Number 2. Is 20 a possible output value? So output is your Y value. So I want to know if 20 works.
Yeah.
I thought it was just $40.
$40 per camper.
Oh,
It brought in $20.
no, because you can't have half a person.
All right, and would be a half. In this case, that doesn't make sense. All right, can't have a half a camper. How about 100?
No.
Why not?
Yes.
What do you mean? You can't have
Yeah, I think it's 2.5. Same reason as the first one. No, those don't work. Not possible in either case. Can't have a half a camper. B. Here are two graphs that relate the number of students in camp revenue in dollars. Which graph could represent the function? Explain why the other one cannot. Which one of those will work?
Oh, B,
The dots.
the dot.
Why?
Because it has to be, it can only go to 60 people.
Yeah, it's got to be a whole number of people. A line means a half, fraction, decimals, everything works. Dot means it's just perfectly whole numbers. Look where the dots are. 5, 6, 7, 8, right? Discrete graph. This is called a continuous. Describe all the possible output values of R. Okay, what was the minimum amount of campers?
5,
5 times 40?
200.
200. So 200 is going to be my lowest amount. Max?
16,
16 times 40.
640.
640. Okay, so I'm going to make note that it is between 200 and 640, but it is multiples of 40. Because every person would add $40, right? 200, 240, 280. It is multiples of 40. Are you ready? If you want to make at least $500, how many students can you have?
12 or more, or 13 or more.
13, 14, 15, and 16. And again, you should see it'll be above 500. 500 doesn't count, it says more than. Yeah, at least $500, so 12 times 40, of course, would be less than it, but there are 4 totals that will work. Last question, 10.4. Consider the following function. Find out what you get if you plug in these for x, but she ran into some trouble, so let's see what happened. Plugging in negative 10 here. So negative 10 minus 2. What is negative 10 minus 2?
Negative 12.
So 6 divided by negative 12.
Negative half.
Negative a half.
What are we? Oh, okay.
Now I'm going to plug in 0 for x. 0 minus 2.
Negative
6 divided by negative 2.
Negative
I'm going to plug in a half for x. Half minus 2 is negative a half, or 1.5. 6 divided by negative 1.5. If you got a calculator handy on you or Desmos, that would make this a little easier for us.
Negative.
What?
Or 1.5, sorry. No, it's
What?
not.
It'd be 12 and then.
6 divided by negative
4.
negative 4, thank you. 2. Plug in 2 for x. 6 divided by 0.
Error. You can't do that.
Undefined, that's called. You cannot take a pie and cut it into 0 pieces. Plug in 8. 8 minus 2 is 6. 6 divided by 6 is 1.
How does a half go into 6 4?
It's 1.5.
It's negative 1.5. So let's use graphing calculator to graph. All right, so I would like you to get Desmos up. Probably gotta put that in parentheses on your Desmos. Let's see what your graph looks like.
Was that one on the bottom say X?
X minus 2. put it in parentheses just to make sure it's together on the bottom.
Oh, that's cool.
Can I borrow this, Tim?
Yes.
Either way, he's gonna.
All right, so here's our graph. Here's what it should look like when you graph it or type it in. Now, what do you notice?
It doesn't go to 0.
Well, it goes to 0. I mean, I got a point there with 0.
Well, it doesn't go to 0, 0,
It doesn't go to what?
The origin.
0, 0.
What number is it not going to touch?
2.
2. So your graph, just going to put a dotted line there. We'll get closer and closer to that number, but never cross it. Why is that one not included? You just told me that from the table. You said it's undefined, it's impossible. Okay, it will never touch that line. It will never touch x equals 2. It says use a calculator to compute the value. You did. Gives you an error message. You can't divide by 0. Okay, how would you describe the domain, the input, the x values? How would you describe that? What x's get touched?
Anything above.
It also goes this way. Anything above 2 means this way.
Anything above 2 or negative 2.
Okay, or can we say anything but?
Anything but -2.
It's not negative.
But anything in between negative 2 and 2 is undefined, or is not there.
No, there's only one number that doesn't work.
2.
2.
And negative
So
2.
all things, no, negative 2 is fine.
Oh, wait, yeah.
All numbers work but 2. Your graph will touch every number on the x scale, going left and right, but 2. You can zoom out as far as you want. That's going to keep on going both ways. Remember, if it's talking domain, it is talking the x values. Okay, we're going to skip this. Are you ready? But I do want you to highlight 2 things in your notes. First one is the first paragraph in the summary. Domain is the input values. Sometimes they all work. Sometimes they don't, as we were talking about with the number of people. If you have a fraction, a denominator, you really have to watch that as well. The range, next page, remember that's your y values, your output. Okay, so just make sure you know where those definitions are. Because if you get them mixed up, every problem will be wrong. If it says, what's the domain? And you're backwards, right? Gotta have that. All right, so take a look at the homework today. I don't think it'll be too difficult. First one, select all. We can handle that. Determine if it's possible. So just circle the ones that work based on the question. 3, select all. 4, what numbers make sense? That's similar to the one we just did with the camp. 5, select all. Oh, 5D looks again formatted wrong. 5D. It's the same thing, I think. Must have just had trouble getting that one to transfer over for some reason. So that should be 5D. Six, use function notation to just show where x and y are for each one. Gonna have 2 answers there. Pretty simple. 7. Find those on your graph, match them. And 8, explain. What's the trouble with that? Is it possible? Is it not? So 8 questions today, lesson 10.